Hello and welcome to this SOFiSTiK tutorial. In this video, I want to show you how to create this T-beam column as a Revit family. We will then use this Revit family in the SOFiSTiK Bridge and Infrastructure Modeler Substructure command. One of the specialities of this family is that we will create it as a nested family, meaning that we will have one main family where we will create the top part of our T column, and a nested family, meaning another family that is hosted by the main family that will consist of the column part of our T column. Additionally, we will of course prepare all of this parametrically, which will then be accessible directly via the Substructure command of the SOFiSTiK Bridge and Infrastructure Modeler. Here we have an overview of the main family, which will on the one hand include parameters for our top part of the column, which will be created directly in this family, but also input for our nested family, meaning that these informations, these parameters, will be translated to our nested family. Then we also have formulas which are going on in the background, which will not be accessible via the Substructure command, but will still do their operations in the background. Here we have a preview of the nested column now. This subfamily has parameters that are directly defined by the user, which will be accessible via the main family, as well as some additional formulas that are happening in the background of this family. Let's jump right into Revit and get started with creating the family. We do that by creating a new family based on the metric generic model adaptive template. In here, we once again start by placing a point element onto our reference plane, aligning it to the other reference planes in the Revit family, and making this point adaptive. This is going to be our reference point for inserting this family later into other families or the project. We actually start by creating the column. Just remember, usually we always start from left to right. So this is also the way we are thinking here. I will use one different style of parametrizing our family in this instance. I will do that by setting the horizontal plane of my adaptive point as a reference and placing 2 point elements into the middle of it. This warning will pop up, which informs us that 2 points exist in the same space. This is fine because, we will move the points away anyway. You can select the point itself via the tab key and move them apart a little bit. And the way of parametrization I want to show you here is via dimension lines. So here you can see that I can assign the dimension line, and as usual, I could just place a value here and my reference point would move along. In this instance, I will show you how to do this based on parameters. What we need for that, of course, is parameters. So we go up here, family types, and create a couple of new ones. I will actually start by creating a height parameter, which is going to be an instance parameter in the group dimensions. And I will simply copy this one and rename it to length, as well as width. For our reference points that we created here, we actually want them to move with the half width of the column that we will create. So now we can create another parameter, which we're gonna call half_width, which is an instance parameter, which is placed via others. So it is separated a little bit. It doesn't have any technical application right here, but it makes the family look a little bit more clean. So what I want this half width to do is to actually take the width parameter, which is going to be accessible via the user, and divide it by 2. Of course, 0 divided by 2 is still 0, so I actually have to assign a value. And now we see, aha, half width is 500. I assign this now to my dimension line by just clicking on it, drop down, and assigning the half width parameter. We can see that the change is applied immediately. Why did I choose this kind of parametrization? I wanted to show you that a part of assigning an offset, we can also use dimension lines to tell the point what to do. But keep in mind, you cannot use negative values like that. It is also not necessary to create negative values in this way, because it will just move away from my insertion point, from my adaptive point, with a distance of 500. I will now move them a little bit out of the way, because one of the disadvantages is that, of course, it uses screen space. But now we want to create the rest of our geometry. To do that, I will actually already create all the other parameters that are necessary, which are half length, then we also need a parameter for negative half length. I like to just add a neg somewhere in there for me to have an indicator what is going on. So a negative half length. And lastly, we also want to have a negative height. I now want to assign them properly. I will just set some values for my input height and for my input length. And what I want to do now is length should be assigned to the half length parameter. So I change this input. Then negative half length can simply be the half length parameter, which is negative. And the negative height simply is the height parameter with a minus in front of it. Then we are already done. I can also move around these parameters in here just for simplification to have length and half length negative next to each other. So far so good. We have all the parameters we want to assign to this family. Now we want to create the column geometry. I start by actually setting a reference plane of my reference points right here, the vertical one, and creating two reference points on it. Keep in mind, this warning will pop up every single time we create points which are already placed on existing points. I set it the second point as well and also place two reference points inside. Now I simply select two of them and I want to assign the offset to them. You can see that those are the ones with the offset of 0. And now I want it to move along via half length. So this is the length of my column. And I do the same thing into the other direction, negative half length. And this is gonna be my linear reference. In between these 2 points, I now want to assign an arc. I can simply do this by assigning the midpoint of the arc, so the horizontal plane of my middle point over here, and creating a 180-degree arc. I made it a little bit bigger on purpose because I want to show you that they are not driven by the insertion points here, but by the reference point in the middle with addition of a dimension line. Do the same thing for my second point over here and just very quickly create my two planes. I can now use the same principle as with these dimension lines to drive the half circles that we created here. I select the dimension lines here in the drop down. I can now select half length. And you can see that they now match perfectly with our offset driven points. Now, before we actually create the reference geometry, we also want to create the height of the column. We can very easily do this by placing reference points in all of our little points that we already created here. So I select the horizontal plane to get a vertical offset. Just place these reference points into them, so we get a warning for every single one of them. Remember, this is because there is already a point in this part of our geometry. This takes a little while, but what we can do now is we can just select all these points that we created and assign an offset to them, which is gonna be our negative height. All we need to do now is once again create our half circles, and then we are basically ready to create our column. So I set the horizontal plane of my midpoint, and I once again use the center end arc command to create this half circle. I now set it, the reference plane, to the other midpoint. And I can just very quickly create those dimension lines, select the parameter that I want to assign to it, and now I can actually make use of these secondary points that I created by selecting two of them and create a spline in between. Now I can select my references that I created and change them to reference lines. I do the same thing for my top reference of my column. Select the secondary points, select all the lines that we created and set them to reference line. Now I can simply select the reference lines on the bottom and click on Create Form. And now we are already finished with creating our column as its own family. Keep in mind, the input that we give here is completely versatile and drives the family that we have here. Now it's time to save this family. I will save it on the desktop and call it column. Now I want to create a second family. So I go to File, New, create a family based on the English metric generic model adaptive. And we'll start once again to working from left to right. I want an adaptive point which is aligned to the middle of my family. And now I want to talk shortly about nesting the other family that we still have open over here into this main family. To do that, keep in mind that we have a project browser over here that allows us to navigate already existing families in our main family. I want to place my adaptive column via this one adaptive point into my main family. To do so, I can actually reference any kind of point or reference line, but the way that I want to show you now is to simply now, once created, create a reference point vertically. So just keep in mind, I'm moving this down, vertical offset, and two of them horizontally. I'll move them apart just for you to see what is actually happening here. So they are all with their respective offsets placed on the reference planes of my adaptive point. I come back to my column family and now I want it to be loaded into my other family. And here you can now see our adaptive point, which is shown in blue over here. And depending on which point I choose, my column is aligned in a certain way. So I actually have to do this once again. You can find your nested family here now via families, generic model, column. And to replace it, you can simply just drag and drop it in here. And what I wanted to show you is if we create our reference point with a vertical offset, so with a horizontal plane, we actually get it aligned perfectly the way we created this column in our nested or in our other family. So I just place it once here. Keep in mind, we can still control this point via our offsets. So I can move this column as I feel like it. Just keep in mind, I will just leave this point down here while I create the rest of the family in a parametric way. I will start by creating my input parameters via the family type. So I create a new instance parameter with the name length column head, which is going to describe the length of our column head, of course. I will copy this one and call it height of my outer part of my column head, of course, which is going to represent the top part of my column head. And I will just continue by copying this one, which is now not the outer part, but the inner part. And I will continue for the rest of the parameters. Once I created these parameters, we can also talk about the column parameters that I have assigned in this picture, where I have my column length, which is an instance parameter. I want to move it all the way down to the end of my list. I copy it, and I also want to have a height information for my column, as well as a width information, or input in this case. So I move it all the way down because those are the parameters that will actually be assigned to my nested family. So I assign them some values like 600, 8,000 and 900. And just leave it like that for now, because as you can see, the family that we have here actually does have their own properties, which are on the other hand assignable, and those are the height, length and width parameters that we created in our original family as height, length, width. By the way, we can close this family now. We don't need it anymore because we already have it in this other family as a nested one. The only thing we have to tell the program now is later on, when we as a user input these values for the column, how will they be translated or transferred to our nested family? And this is just by assigning the height here to our column height, the length to our column length, and the width to our column width. You can immediately see that the changes are applied. All right, let's come back to our parameters that are assigned to our main family, where the length of our column head will be 1000, so 1 meter, 300, 600, 600, 6000 instead of 100, and 1600. These values will all be accessible via the interface substructure of the SOFiSTiK Bridge Infrastructure Modeler. Now I also want to add operations which are happening in the background. For example, I want one parameter for the half width of my outer part, simply to automate the process of creating the geometry according to the input. Alright, now that we finished creating the parameters, we are ready to apply and save them. And we can now create the reference geometry for our column head. I will start by assigning the longitudinal offset, which is my first parameter that I define. So I will just create one reference point and I will assign the column head length, half of it, to this parameter. I can also assign a negative half, doesn't really matter. We will need both. Because now, based on this insertion point, I will create all the other necessary points for this family. To do so, we first up want 2 points here on top with the offset horizontally. You can see here I assigned a horizontal offset to this one, and to this parameter we want to assign the width of the column head, especially half width of the outer part, as well as the negative half width of the outer part. So the outer part is done, so I can actually start with the lower portion of my 2 outer points, and I can very quickly just assign the horizontal plane of these points, create my reference points inside of them, so I do get this warning, and I can now assign the negative height of my outer part. So the reference for my outside geometry is already done. Now I want to have the middle of my column head to be referenced. To do so, I want to have one middle point, so based on my one offset point that I have here, with a vertical offset, which gets assigned the negative height of my inner part. Based on this one, I can now assign the width of my inner part, and we are as good as done by then. So we need 2 more points in this one. I assign one time the half width of my inner part, which I will find here. And one time I do simply assign the negative half width of my inner part. Now we can use the same principle as we did for our column, where we just assigned points to every single geometry defining point and give it an offset, or we create the same geometry on the other side, but the easiest way is just our geometry defining points, which on the one hand is this one, next one is this one. By the way, if you select the point element function and then set a new work plane, the command stays active, so I can just keep going the way I do it here. By the way, we don't need insertion points for this one and this one anymore, so we can just keep going with our base geometry here. Once I created all these points, I can now click at all of them and assign the offset, which is my column head length. Once I assign it, I have all my geometry defining points done. All there is left to do is to connect 2 by 2 together to get our reference geometry in the front and back of our column head. To do so, I just very quickly go like this, select 2 of them, and once we finished the front row, we can do the back row. And I can of course also rotate around to make it a little easier to select the points. And once I finish that, I now have all the lines done. Once I finish that, I can select both front and back lines, change them to reference lines, and select them once again, click Create Form, and we are done. The only thing left to create our T column is to now assign the proper height to the offset of our column top, which is the negative height of our inner part. Once I select it, everything is perfectly aligned. So far so good. This is all that is necessary to create a nested column family like this one. Just to show you very quickly, we will start a new project. Just as simple as this. I will go to 3D and very quickly start the SOFiSTiK Bridge and Infrastructure Modeler to create a quick axis. And here we can now either load the standard families, or we can also load our column family into the project. It's called main family, or I called it main family when I saved it. And it is now assigned easily accessible because it's already loaded into the project via the substructure command. Again, the substructure command, the first time we click it, loads in all the families which we assign via the create dropdown here, but also our main family. So once I click on OK, the main family is created exactly where we align it to our axis. And all the parameters that we assigned in here are now modifiable. So I could change the width of my column here, could change it to something that it's actually just the two circles defining it. I can change it back, I can make it very long and see the changes in real time which are assigned to this column. Thank you very much for watching. I hope you are having a great time with the SOFiSTiK Bridge and Infrastructure Modeler.